Good morning, dear students. Hope you are doing good. Wherever you are, stay safe and stay home. Dear students, in the previous class, we have discussed a problem to design a suitable sedimentation tank. Now, we'll focus one more problem on design of sedimentation tank with the given values and specifications. Before that, I'm asking you everyone to practice the problem, the values taken by yourself. What I'm specifically mentioning is practice such type of problems with other possible values. And I'm sure that if we are allowed for offline classes, that means if situation becomes well, or else whenever the situation becomes good, and if any possibility of offline classes, definitely I'll make you practice all these problems, and I'll make you to solve on blackboard also. The treatment works is most mandatory part in any water supply, and you must be aware how to design all these plants, how to overcome the problem of water contamination before the water is being supplied to the public. So as an engineer, you must face huge amount of contaminated water, and you are the responsible to treat the water, and you are the responsible to supply the water to the public if you are appointed as an authorized engineer. That is the reason you must get full knowledge on the working process of these treatment plants. Hoping that you are very much confident about the topics what we discussed so far. And we are very much keen all these sessions regarding the concept of, regarding to know the concept of these treatment methodologies. So regularly I'm observing, regularly even I'm also following how many people are listening to the classes to Google Classrooms. Regularly I'm following and regularly I'm noting down. We are in the 4th unit. We are discussing, of course, we already discussed different technologies for water treatment. And also we have seen the different considerations for design of sedimentary tanks, where we have seen the design of inlet zone, design of settling zone, design of sludge zone, design of outlet zone. Along with that, we already seen the other specifications, in the sense the types of sedimentation tanks and working procedure of those sedimentation tanks, in the name of circular sedimentation tanks, rectangular sedimentation tanks, hopper bottom sedimentation tanks, so on. Today we'll discuss one more problem on this design of sedimentation tanks. Hope you all understood yesterday's problem. On design of sedimentation tanks. We are here this is the problem what we discussed in the previous class, and hope you are very much confident about this problem, how we got and how we design the sedimentation tank with the given values. Now we'll see the other problem. Dear students, have a look on the question and what are all the values we have before, what are all the specifications we have before we are going to design this sedimentation tank. See, there is a quantity of water, that is 1.4 into 10 power 6 liters per day, has to be treated within the detention period of 5 hours. What is detention period? You know, the time that has taken for a particle of water in a settling chamber from the entry to exit of the tank. See here, we have a detention period of 5 hours, and the flow velocity is adjusted 12 centimeters per minute. And depth here they are given. In the previous case, there is no depth. They didn't give the depth. So what we done? Simply, we are assumed the depth as 3.5. This is in the previous session. Now they are given the depth. And one more also they are given with allowance of sludge 80 centimeters. What is sludge? That is semi-solid mud. Yeah. What is sludge zone? We have seen. After settling of particles, the sludge will be taken off by using sludge pipe. Did you understand? Did you remember? This is a sludge pipe. How much of sludge is allowed to be there? Up to 80 centimeters. Allowance of sludge is 80 centimeters. Now we'll see. Again, what are the values we have? What are the values we have? Simply the quantity of water we have, detention period we have, flow velocity we have, Depth already given and sludge allowance is 80 centimeters. Now we'll see one after one. Now quantity of water to be treated in 24 hours. 1.4 into 10 power 6 liters per day. When? During the detention period of 5 hours. During the detention period of 5 hours. That means 5 hours in the sense 5 into 60 we have seen. See here, of course, that is flow velocity. See here, in 8 hours, how much we got? 3 into 10 power 6. Here, this is within the detention period of 5 hours. Now the value we have is, take the cals and do it now. This is 291.67 meter cube. Let us say 292 cubic meters. Now, capacity of sedimentation tank required is 292 meter cube. Okay. Then we have flow velocity, that is, we have flow velocity that is 12 centimeters. We are just converting into 0.1 when the centimeter is converting into meters. Then we'll get 0.12 meters per minute. Why here minutes? The detention period is 5 hours. So we are just converting into 5 into 60 minutes. That means whatever we got the value will be used to find out the length of the tank. Length of the tank, what is length of the tank? Flow velocity into detention time. See what is 0.12 into 5 into 60 minutes. Now the length is 36 minutes. Sorry, 36 meters. We got the capacity. How we got the capacity? Simply into 5 for 24 hours. So 1.4 into 10.6 by 24. When is the what is the detention period? 5 hours. So this is the value we got. To find out the velocity of flow, we are just converting centimeters to meters. To find out the length of the tank, the formula velocity in detention time where 0.12 into 5 into 60 minutes. Am I right? 60 minutes per hour, right? So 5 into 60. Now we got the length, that is 36 meters. We'll go to the next table. Sludge allowance. They allowed the sludge for up to 80 centimeters. They allowed the sludge up to 80 centimeters. That means again the centimeter is converting into meters. We got 0.8 meters. So depth of the water in actual, what is the depth they are given? Depth in the tank is 4.0 meters. And in that depth, they allowed 80 centimeters for sludge. They given the value. Okay. The depth of the water in actual is how much? 4.0, 4 meters. That means they allowed sludge 80 centimeters. That means 0.8 meters. So now the available depth of water, depth for water is 3.2. Why? Because 80 centimeter is allowed for sludge. 80 centimeters means 0.8 meters. And they are given the depth 4 meters. In that 4 meters, 0.8 meters is allowed for sludge settling. Sludge. Now we have the depth also. You see, whereas in the previous case, they didn't give the depth. We only assumed the depth as 3.5 meters. I told you in the previous class, if the depth is not mentioned, we must assume the depth as 3.5 meters. That is a pre-prescribed and empirical. Now is area. What is the formula? Capacity by length of the tank. What is the capacity we got? 292. How we got? Simply the quantity of water to be treated in a day. In a day in the sense 24 hours. During the detention period of 5 hours. Then we'll get the quantity of water to be treated. That means capacity of water that is required. 292 cubic meters. So what is the capacity? 292. What is the length? We got 36 meters. So length is 292 by 36 meters. Now we got area 8.11 meters square. What are the values we got so far? We got the capacity, we got the length, and we got the depth. Now what we should get? Width. What is the width of the tank? What is the formula for width of the tank? Area by depth. Am I right? What is the formula? Area by depth. What is the area? 8.11 by what is the depth? 3.2. Why it is 3.2? They given the 4, but they only allowed for sludge deposition 0.82, 0.8. So the water in the tank, the depth of the water in the tank is 0.3. We must take this value. Width of the tank 8.11 by 3.2. This is 2.5 and 2.53 something else. We round off 2.5. Assume freeboard. They didn't give the freeboard. They didn't mention the freeboard here. They only mentioned the depth. See here in the previous case, they didn't give the depth, even they didn't give the freeboard. So we just assumed 3.5 meters as depth, and we assumed 0.4, 0.5 meters we are provided to the depth of the tank as a freeboard. In the same way, assume freeboard at 0.5 meters. So depth is 0.5 plus 4.0 overall depth equal 4.5 meters. This depth is for water. In actual, for water storage, 3.2 meters only water, up to 3.2 meters only water can be in the tank, because the 8 centimeters, 0.8 meters is allowed for sludge. So now to the depth, overall depth 0.5 plus 4.0, that is 4.5 meters. Now depth of dimensions of the tank is 36 meters. What it is? 36 meters of length, 2.5 meters of width, 4.5 meters of depth. Now we got all the dimensions: length, width, and depth. This is the other type of problem where we have the sludge allowance of 80 centimeters. See here, we have given the values, that is the quantity of water to be treated. They given the detention period, they given the flow velocity, and they given the depth, and also they given the sludge allowance. See here, in the previous case, fitted with mechanical sludge remover, whatever the sludge formed, that will be removed. That will be removed by mechanical sludge removers. But here, whatever the sludge formed, that is allowed up to 80 centimeters. The topic of sludge is here also, but whereas in the previous instance, the sludge will be removed by mechanical sludge removers. Now the sludge is allowed to settle, or as the sludge allowance is 80 centimeters. They given the flow velocity, they given the sludge allowance, they given the depth, they given the detention period, they given the quantity of water to be treated. That is the reason. With this, the given specifications, at last we found the dimensions. First, we found the capacity of sedimentation tank that is required. Simply during the detention period, the total quantity to be treated by 24 into 5, we got the capacity. Flow velocity is given centimeters, we just converted into meters, 0.12 meters, because the length of the tank is velocity into detention time. Detention time is 5 into 60 minutes. Now we'll get the value as 36 meters. Length, sludge allowance is 80 centimeters, but we are just going with 0.8 meters. Now, so depth of the water actually is 4 meters. From 4 meters to, we have just substituted 0.8 meters, because it has given 8 centimeters, 80 centimeters. Now we converted into meters, 8 meters. For 4 meters to minus 0.8, that is 3.2 meters of depth. Area will be find out with the formula of capacity by length. Capacity is 292. We got here capacity of water that is required. 292 by length. We got here 2 point length is 36. 292 by 36 equal to, now the value we got it is 8.11 meters square. Now width of the tank 8.11 by area by depth. What is the area? 8.11. What is the depth here? Actual depth 3.2. Now we get the width as 2.5 meters. And now assume the freeboard 0.5 meters. So depth is 0.5 plus 4.0 meters. Total overall 4.5 meters. Dimensions of tank that is required are dimensions of the tank required are 36 meters of length, 2.5 meters of width, 4.5 meters of depth. Hope you understood this problem. If you have any doubts, please contact the domain, whatever you feel convenient, either phone, message, or mail. Once if online classes started, if any possibility of online classes, definitely we'll make sure to learn this type of problems few more. Thank you. Thanks a lot. We'll meet in the previous class.